Now the question which arises here, that which one will liberate at cathode and which one will be liberated at anode, or which one will be deposited. Okay. Now this answer will give you this reduction potential values. Okay. Now if I think very clearly, okay, that excuse me, okay, that this process, the sodium is forming sodium, so sodium plus is forming sodium. This process is reduction process. Okay. So this is their reduction potential value. Water is forming hydrogen. This is also reduction process. So it is forming, giving the reduction potential value true. Now this process, this source Cl minus to Cl2, this is the oxidation process. So I'm reporting here is what? Reduction potential. Okay. And this water to oxygen formation, this is also oxidation process. So this I'm reporting here is reduction potential. Okay. Now if I here, this point is very interesting and very conceptual part. So listen very carefully. This part. Okay. Now if I draw a line, okay, if I draw the line, okay, this is the zero scale. Okay. Acha. Let's write down those numerical values. First value is 0.83 volt. 0.83 volt, which is this one. Next value is minus, this is minus 1.23 volt. Okay. Next value minus 1.36 volt, and next value minus 2.71 volt. Now if you go downwards, okay, the value of the reduction potential decreases, right? It is more negative value. And what we know that delta G is equal to minus, delta G0 is equal to minus of NFE0. That means if your E is negative, then your delta G is positive, right? So that means if you go, the reaction suggests delta G positive value suggests the reaction is not spontaneous. Hmm? Now, if you go downwards, the E reduction value becomes more negative. That means what? Your delta G becomes more positive. That means from going down the value, the species will be less prone towards reduction. So if it is less prone towards reduction, that means it is more prone towards oxidation. Okay. So if I go the downwards, the getting oxidized increases, getting oxidized tendency increases. Clear? Okay. And if I go up, just the opposite, getting reduced tendency increases. Right? Keep this in mind. If I go down towards a more negative value of reduction potential, the species will be more prone towards oxidation compared to reduction. Now, here, if I see the values, okay, let's first check these two values between this reaction, the sodium and your water. So sodium is minus 2.71 and hydrogen is minus 0.8. So this is the one value and this is the one value, another value. Okay. Now between these two values, if you see that sodium is more negative compared to the hydrogen. Okay, compared to hydrogen. That means sodium will always try to get oxidized, whereas hydrogen will try to get reduced. Sodium will have higher tendency to get oxidized, and compared to sodium, the hydrogen here, the water hydrogen, this reaction will be more prone towards the reduction. That means in between them, if I think about the due to the low, your more positive direction, the reduction potential, low negative I would say, reduction potential will leads to this reaction is more spontaneous in the solution, and it suggests that at your negative electrode, that is the cathode, your hydrogen gas will be liberated. So here in between sodium and hydrogen H plus, your I'm sorry here hydrogen gas will be liberated, right? Your hydrogen gas will be liberated. Similarly, if I think about the Cl minus and water, see Cl minus is minus 36, 1.36 and oxygen is minus 1.23 volt reduction potential. Now these are the oxidation processes. Now Cl minus to Cl2, this is more negative compared to the oxygen formation. That means the Cl minus will have more tendency towards oxidation, right? Cl minus will easily your lose electron and it will form Cl2 compared to the oxygen formation. So that's why this is the reason why your the in from your anode you get Cl2 gas is liberated. So when you perform an electrolysis in the aqueous sodium chloride solution, you always get in anode you sorry in cathode you get hydrogen liberation, and in cathode you get anode you get chlorine gas liberation. So this is the electrolysis topic which you will encounter in your exams, and this is the more conceptual way to describe using the reduction potential value the spontaneity of the reaction, and which one will be win and which one will be liberated in both cathode and anode, either they will be uh, deposited. Okay, so this is the now this thing is huge, has a huge application in case of in metallurgy, where you perform electroplating or the extraction of different metals from ore. There you have different, this application is a huge application there. Okay, so next lecture, so this is all for the electrolysis process what you have in your syllabus. And next what I will start is this application of the electricity in a solution. Let's say if you have a solution and you pass electricity through the solution, so how the ions will behave towards them. That means you can I take an idea, guess that which way I'm directing. I'm going towards the ionic solution and their conductance part. Okay. And then next what I will do after that, I will discuss the different kinds of batteries present in your this electrochemistry, different kinds of batteries, fuel cell, and after that I will discuss many numerical problems based on this chapter and different equations, and then your this electrochemistry chapter will end. Okay, so tune to next video.